Hello friends, today I'm going to talk to you about some misconceptions that are there in mechanical vibrations theory in the mind of many people. If you want to understand mechanical vibration theory better, I suggest that you give up these four misconceptions. So, I introduced by saying that vibration is an interesting topic, but it has a lot of prerequisites like mathematics, statics, dynamics, etc. So, since so much of mathematics is involved, it is easy to come to some misconceptions. So, I'll be talking to you about some of the misconceptions that I had, which I later outgrew. So, I'm making this video so that those who are learning the vibration theory can avoid these misconceptions. So, first one, resonance causes vibrations of infinite amplitude. So, this was something that I uh, had a misconception about. But anyway, the basic theory itself is clear. So how actually I acquired this misconception was that initially all theory they teach in terms of undamped vibration. So I assume that the same thing applies for damped vibration also. So that's how for undamped vibration it can be infinity, but not for damped. But I assumed it is. So this is one of the misconceptions that I had, which I later outgrew. The next misconception that I had was that the response of a forced vibration of one DOF system subject to harmonic loads is simple harmonic. So here I want to say that only the steady state response is harmonic, not the total response. So the total response consists of the steady state response and the transient response. So the total response is not harmonic. So if you see the actual structure and see how it vibrates, it will not be it will not be simple harmonic. So but if you see the steady state, it will be harmonic. So this is one of the misconceptions that I had, which I outgrew later. And what I would like to say is the total response is not harmonic. I imagine that it will be like what it is in the figure 2, but it is actually like what it is in the figure 3. So this is for undamped vibrations alone. For damped vibrations, the transient response will die out and steady state will be harmonic. So third conception was, so I assumed, since I had assumed that the the total response is simple harmonics, a simple sine wave. So I assume that in quarter of a cycle, infinite amplitude will be reached. However, that is not true. So the buildup of amplitude takes place slowly, little by little. So it takes time for the amplitude to build up. And what you can see on the screen is for undamped vibrations. Now, even if you change it to damped vibrations, it will be somewhat like this. So even in the damped vibration, you can see it takes some time for the maximum amplitude to be reached. So yeah, but you can see the comparison between the undamped and damped. In undamped vibration, at resonance, the amplitude just goes on increasing with time, and reaches in and extends towards infinity as the time increases. So, but however, in damped vibrations, after a few cycles, the vibration attains steady state uh, and does not increase further. So this is the another misconception I had. Then another misconception that I have seen in many people, and I had myself, was that if the natural frequency and the frequency of excitation match, it always causes violent vibrations in the structure. That is not true. So there is something called mode participation factor and mass participation factor. So those things you should know. So for example, if you consider a rod with a point mass at the end, like what is shown in the figure 6. Now, for the axial vibration, it has some natural frequency, and for the lateral vibration, it has some other natural frequency. Now, let us say the lateral vibration has a natural frequency of 10, but instead we are excited in the natural frequency of 10 radians per second in the axial direction. So the transverse so the frequency in the transverse motion is 10 radians per second, but instead we are exciting in axially in 10 radians per second. So it will not cause resonance because the mode participation factor here is 0. So this is something that I wanted to show you. So here, even though the natural frequency and the frequency of excitation are the same, violent vibrations don't take place because the mode participation factor is 0. So this is something that I wanted to share with you. Thank you for watching this video.